Hello and welcome to another Cashmatics video. Now in this video we're going to follow on from the last one. This is part 2 of a series of videos teaching you how to do some fairly straightforward differentiation to begin with, and then slowly building upon those skills. So what I've got on the screen at the moment is some basic derivatives, and you can find these in your formula book. The derivative of sine x is cos x becomes minus sine x, e to the x becomes e to the x, and ln x becomes 1 over x. And what we're going to do is we're going to use these basic derivatives to help us to differentiate what I call a function of a function. Okay, and we're going to use something called the chain rule. But once we get used to using the chain rule, what we're going to do is we're going to see if we can do it by inspection instead. Now what the chain rule says is dy by dx is equal to dy by du times by du by dx. So basically these two cancel each other out to leave you with dy by dx. Okay, and just keep these derivatives in mind because we are going to be using these. Okay, and I'll give you a simple example to begin with. Let's just say y equals the sine of x squared. Okay, so y equals the sine of x squared. So the way we do this is we first of all say, okay, let's look at the order of these operations. Okay, the order of the operations in this is x is getting squared first, and then we're taking the sine of whatever the value of x squared is. Okay, now when it comes to understanding which order we need to apply the chain rule in, you've got to think a little bit like BIDMAS. Okay, so x squared is happening first, and then sine. Okay, so sine is the last thing that's happening. So the function on the inside is actually your square function. That's the one we're going to replace with u. Okay, so if I say let u equal x squared, okay, and what I need, if you look at the sine rule, sorry, the chain rule, it says I need du by dx. So I'm going to just write down what du by dx is, and you should all be able to tell me that is 2x. All right, so if u is equal to x squared, then du by dx is equal to 2. But if u is equal to x squared, that means this here becomes y equals the sine of u, which means dy by dx, sorry, dy by du, sorry, so this is y in terms of u, dy by du would be cos u. Right, so what I've got here is just this derivative being applied. So from here I've got everything I need to actually differentiate this. So let's just put it in a different color. Dy by dx is equal to dy by du, so dy by du, which is cos u, times by du by dx, which is 2x. So that is 2x cos u. But we need to write it back in its original terms, which is in terms of x. So because u is equal to x squared, okay, u is equal to x squared, this becomes 2x cos of x squared, and I'll just put that in brackets to make it clear. Okay, now I will do a few more examples, and then what we'll do is we'll look to see how we can do this just by inspection rather than by writing you know, the whole thing that I've got in blue. Alright, but if you are unsure about how to do it by inspection once we get to it, just follow this method and it should work. Alright, so let's just have a look at another example. So let's say we had y is equal to e to the 3x squared plus 4x. Okay, something like that. Right, so this is an e function. It's e to the something. Okay, so and the something is a function of x. So it's that function of x which I need to write down as u. So if I say let u equal 3x squared plus 4x, and remember we need to differentiate this, so du by dx would equal 6x plus 4, and this over here becomes y equals e to the u. Now that's quite a simple derivative. Dy by du would equal e to the u as well. Alright, so that's quite straightforward. So we've got everything we need now. So let's just put it all together. So dy by dx, oops, let's write that a little bit neater, is equal to dy by du times by du by dx. Okay, remember the du's cancel each other out. So dy by du is e to the power u multiplied by du by dx, which is 6x plus 4. Okay, and remember it's multiplied by all of that, so let's stick that in brackets. And we need to write down the u in terms of x. So u is actually equal to 3x squared plus 4. So I'm going to write that down, and I'm going to swap these around at the same time. Okay, so I'm going to write 6x plus 4, so that's just this bit being written first, e to the power u, so it's e to the power 3x squared add 4x. Okay, so that's that one done. Right, let's have a look at another example. Let's say we had something like y equals the natural log of sine x. So the natural log of sine x. So it's the log of something, that's the function. Okay, it's a log of something, but that something is also a function of x. So that's the one I need to replace with u. Okay, so let's say u equals sine x, and du by dx would equal cos x. Okay, now because u is sine x, this becomes y equals ln u. So when you differentiate ln u, so dy by du, so ln something becomes 1 over something, so that would be 1 over u. We've got everything we need. Look, we just write dy by dx equals dy by du multiplied by du by dx, and dy by du is 1 over u multiplied by du by dx, which is cos x, but u is actually equal to sine x, so what I get is cos x over sine x. And if sine over cos is tan, cos over sine is 1 over tan, and 1 over tan is called cot, so that would be cot x. Now once you get used to these, you can actually do this without having to write down all the derivatives in the middle. Okay, you can actually do this by inspection, but it does take a bit of time to get used to it to see what's going on. But I'll do a few examples without doing all the working I did before. So let's say we had something like y equals the cos of let's say x squared plus 4. Okay, now if I want to work out what dy by dx is, so if I want to do this in one go, and I'll tidy it up afterwards, all I've got to think is, what does cos something become? Cos something just becomes sine minus sine something. Okay, so it'd be minus sine of whatever it was, so x squared plus 4. And all I need to do then is multiply it by the derivative of what that something is. So this was cos something, which becomes minus sine something. So we need to differentiate the something. So we multiply it by 2x. So this is the derivative of this bit. Okay. So it's the derivative of that bit. So let's just tidy this up. It'll be minus 2x sine x squared plus 4. Okay, so I am applying the chain rule, but I'm just doing it without all the working. But like I said, this takes a bit of getting used to. So once you can spot it, it becomes much easier. Okay, I'll do one more, just so you can see how it works. And then what we'll do is we'll do some slightly trickier functions of functions. Right, so let's say we've got y equals e to the sine 3x. Okay, e to the sine 3x. So dy by dx. Now e to the sine something, e to the something becomes e to the something. So this will still be e to the sine 3x multiplied by the derivative of sine 3x. Now if you remember from the last video, sine 3x will become 3 cos 3x. So overall, my derivative is 3 cos 3x multiplied by e to the sine 3x. Okay, so I've just done that again by inspection. The formula, the function here, sine 3x, is a bit trickier because you've got a function inside the function over there as well. But it's one that you should be used to from before. Right, now we're going to look at another function of a function. This one's going to be a little bit trickier. So let's just say we've got something like y equals sine cubed of x. Okay, so sine cubed of x, let me just get rid of that dot, it should be over here. Okay, sine cubed of x. Now what you need to remember, sine cubed x, I'll just write it over here, sine cubed x actually means the sine of x all cubed. Okay, and people often forget that that's what it actually means. So we're doing the sine of x and then we're cubing it. Okay, so this is a little bit like me saying, well, it's not a little bit like it is it. Okay, let u equal sine x. Okay, so let u equal sine x, so therefore du by dx would equal cos x, and then this here becomes y equals u cubed. Okay, because u is sine x, so this is u cubed. Okay, so dy by du would equal 3u squared, right? And if I was to apply my chain rule, I'll write it down again. Dy by dx is equal to dy by du multiplied by du by dx. Dy by dx would equal, now dy by du, which is 3u squared, multiplied by du by dx, which is cos x. And the u bit, 3u squared, now u is sine x, so it's 3 sine x all squared, which you write as 3 sine squared x, multiplied by cos x, so cos x. So 3 sine squared x cos x. Right, now to finish with, we're going to try something a little bit more complicated. So let's say we had something like y equals sine squared, let's say 3x to the power 4. Okay, so sine squared 3x to the power 4. I'm just going to rewrite this so we understand what this means. So this means the sine of 3x to the power 4 all squared. Okay, so we need to be careful about what we're doing here. So let's just have a quick look. All right, let's pick another color. So let's say let u equal the sine of 3x to the power 4. Okay, so imagine we had to differentiate this bit first. Well, we don't need to imagine it, we do actually have to do it. Okay, sine something becomes cos something, so this would be cos of 3x to the power 4 multiplied by the derivative of this. Okay, so multiplied by 12x cubed. Okay, so this becomes 12x cubed cos 3x to the power 4. Okay, so that little thing in itself is a function of a function. But what we've got over here is a function of a function of a function. So it's like 3 layers deep. But we've actually simplified the problem considerably, because what we need to do here is just replace this with u. Okay, so this is actually, because u is all of this thing inside the bracket, this is just u squared. And dy by du would just be 2u. Okay, so we've got it all now, so we just need to put it all together. Dy by dx is equal to dy by du times by du by dx, and dy by du is 2u multiplied by du by dx, which is all of this over here. Okay, so 12x cubed cos 3x to the power 4, but u is equal to sine 3x to the power 4, so it'll be 2 sine 3x to the power 4 multiplied by 12x cubed cos 3x to the power 4, and you could tidy that up if you needed to. So I'd probably write it as 24x cubed sine 3x to the power 4 cos 3x to the power 4, and there's even an identity you could use to tidy that up as well. But for now, I'm not going to bother with that because that's something for another lesson. But I'm just giving you the basics of how to use the chain rule. Okay, we can worry about the identities that would simplify it further another time. So I hope that's helped with the chain rule, and next time we'll move on to what's called the product rule, and then from there we'll go on to the quotient rule, and then we might look at a few other trig functions, particularly the reciprocal functions, which we can differentiate using the product rule and the quotient rule. But for now, that's all, and I hope that's helped you with the chain rule. See you next time.